Hi guys, I'm here, and I know that you can't see me, but you can see the machine. Today what we're going to be doing is Investigation 11, determining the rate law based on the fading of crystal violet. We'll be measuring absorbance with our Spec 20, and then creating a standard curve for the substance, crystal violet, and then measuring absorbance over a chemical or for a chemical reaction, which is going to be changing the concentration of crystal violet versus time. And from our standard curve, we'll be able to determine a change in concentration over time. And then by graphing our data in 3 ways, concentration versus time, natural log of concentration versus time, and then the inverse of concentration versus time, we'll be able to see if this chemical reaction, which occurs between crystal violet and sodium hydroxide, is a 0, first, or second order process. So to start, I've made a series of dilutions. They range from my blank, and then 1.25 micromolar, through my stock solution, which is 25 micromolar. So what I'm going to be doing is reading a concentration and then reading an absorbance. You guys will record your data, but what you guys will then do, once we have our data on your own, is determine how I made the dilutions from my stock solution. So I'll tell you now, but I'll also state it at the end. The concentration of my stock solution is 25 micromolar. So to start, I've chosen an appropriate wavelength, 540 nanometers. I did this by looking at the curve that was provided to me within my lab document. Remember from our last experiment that we would like to collect reliable data. And reliable data on a machine like this is an absorbance value that falls between 0.2 and 1. So using the curve that was provided, I chose a wavelength of 540 nanometers as being the best to provide me data within that range. At this absorbance, I'm going to create my standard curve. First, I have to make sure that this machine is calibrated, so I'm going to take my blank and change it so then I'm at 0. Okay. Now I'm able to take my absorbance data. My first dilution has a concentration of 1.25 micromolar. And the absorbance here is 0.137. My next dilution, 2.5 micromolar, has an absorbance of 2.55. My next dilution has a concentration of 5 micromolar. Its absorbance, 5.532. Next, 7.5 micromolar. Zero point 808. Ten micromolar. 1.010. 12.5 micromolar. One 0.330. 15 micromolar is next. I'm approaching the top of my range for this machine. For 15 micromolar, I get 1.520, and I have a feeling maybe I'll max out at 20. We'll see. 20 micromolar. I've maxed out at 20. I'm not going to bother to read my stock solution. And I'm going to move on, use my data, and create a standard curve. Alrighty guys, I'm back. What we're going to be doing now is collecting data of concentration of crystal violet over time as it reacts with sodium hydroxide. As it reacts with sodium hydroxide, the crystal violet color, well, crystal violet itself obviously will change. There's a reaction happening. The color will disappear, and that will measure as a change in absorbance and eventually convert to a change in concentration over time. The reaction that we are going to carry out is with 3 milliliters of our stock 25 micromolar solution to 2 milliliters of a 0.0 molar sodium hydroxide solution. This initially is going to mimic one of our dilutions. The absorbance of that dilution was right about at 1, which means that all of my data should happen within a nice, reliable range. So again, that range is 0.2 up to 1. All that we can hope is this reaction proceeds slow enough so that we can get lots of data points. So I have my 3 milliliters of crystal violet here in my cuvette. I have my blank here in my spectrophotometer. What I'm going to do now is remove my blank, and then as quickly as I possibly can, I am going to add the sodium hydroxide solution to my cuvette, hit start, and write down absorbances every 15 seconds until I'm out of my range. So again, here I'm looking at 2 mils. All right. Ready, set, go. Okay. Mixing it, and now I'm adding it. 1.3 was 30 seconds or 15 seconds. 1.14 was 30 seconds. 0.980. 0.835. 0.720. 0.835. 0.620. Point 530. Point 460. Okay, everybody, I'm back for data analysis. So the first thing that I'd like to do, and I'm not sure if I've done this with you yet or not, is to review the data from the instrumentation practice, which is here on the left. Okay, I've highlighted it. It's in bold. Maybe you can see it a little bit better. But what we did was for several dilutions, measured absorbance. Okay. So at a concentration of 0, that was my blank. I set the absorbance to 0. This concentration has units of micromolar. So I'll put that in. 1.25 micromolar, absorbance is 0.137. 2.5 micromolar, absorbance is 0.255. 5 micromolar, absorbance is 0.532. 7.5 micromolar, absorbance is 0.808. And at 10 micromolar, the absorbance is 1.01. 12.5 micromolar, the absorbance is 1.33. And at 15 micromolar, the absorbance is 1.52. We did have 2 other concentrations, but their absorbances they were outside the range that the device could read, so it did not include them. I made a simple plot over here. Okay. Where concentration is on the x-axis and absorbance is on the y-axis. I asked Excel to plot a line of best fit. I do that through here, trend line, more options, and then I can display the equation of the line on the graph, which I have here. I need this, it's very important, because that slope, 0.1027, is what is going to enable me to work with or manipulate the data from the inquiry part of the lab. Okay. So I'm going to move this out of the way. And what I have over here now is my data from the inquiry portion. I collected data for a long period of time. And now what I need to do is select the data that I am going to use. The lab suggests that I collect data until the absorbance is about 10 to 20% of the original value or the initial value. So my initial reading at 15 seconds was 1.3. So I don't know, 20% is like 0.2. So maybe I'll read to here, and then I'll delete the rest. In fact, maybe I won't delete it. I'll just move it out of range. Okay. So now what I need to do is make 3 plots. Because in this portion of the lab, I'm looking at a reaction that occurs between my dye, crystal violet, and sodium hydroxide. And I'm asked, based on how concentration changes with time, what overall order is this process with respect to crystal violet? First, 0, first, or second? All right. Well, I have my absorbance values, and I can use the standard curve generated to convert or calculate from those absorbance values a concentration. And I simply do that by taking my absorbance and dividing it by the slope that I found on my standard curve. I'm going to go ahead and do that for all of these. Then, with those concentrations, I am going to manipulate them. I'm going to do the natural log. Oops. And then I'm also going to do the inverse of concentration. Right. Now what I need to do is plot these, or plot this data to determine the order. Remember, the one that gives me a linear plot would indicate the order of the overall process or the process with respect to crystal violet. All right, so my first graph, X and Y. Insert, scatter plot. Title this concentration of CV versus time. Add my axes, time, concentration. All right. That is clearly not a linear plot. Moving it off to the side. Let's see what a plot of time versus the natural log of concentration looks like. Better. Now here, this data at the end here is a little suspect. This is perfectly linear. Let's look at what we got here for our final graph. The Yeah. So if we look here, what my plan is to remove data after 150 seconds. Actually, and the best way to do that, I guess, would be this. Okay, so let's do this. All right. So now if we look at our three graphs, this is not linear. I could plot a line just to show you that it's not. So you can see here, this line of best fit is really not terrific. But if we come here and we do a line of best fit, you can see that this is beautiful. It's linear. This is first order, experimentally determined. If you look at literature, this process is first order, so this graph is correct. And if I took the slope of the line, so if I wanted to include more options, display the equation, I could determine the slope to be k. All right? All right. So that is it. Hopefully you guys were able to make these plots as I did. Hopefully you've had enough time to record the data. What I recommend that you do is that you pause the video to record the data. You have a nice format here for a data table, and you should be able to do the remainder of what's asked for you on your own. Good luck, guys.